Okay, hello class. We're going to start the year of Algebra 2 by covering some function basics. Algebra 2 Algebra 2 is the study of many types of different functions. So what we want to start kind of our groundwork with is by talking about, well, what is a function? Defining it, learning about some of the basics about functions, and then every single chapter we're going to continue talking about different kinds of functions. So what is a function? Well, actually, let's back up and actually ask ourselves first, what is a relation? A relation is just a connection between two numbers. It's a relationship between two numbers. A relation can be represented in different ways. The first way that you might have learned is through an ordered pair. So we have two sets. We have a set of ordered pairs. We have our input and our output. Our input and our output. Now we can also diagram this differently, actually by a diagram, where on one side we have the set of all the inputs, and on the other side we have the set of all the outputs, and then we have these arrows that shows the relationships. So you can see in this case here 1, 1, we have an arrow across here, 1, negative 1, we have an arrow across here. We can also diagram this relation with a table. Very simple. We can represent the relation with an equation. And you notice it's not, y is equal, it doesn't have to be. In this case, y squared is equal to x. And you'll find that any of these points, if we were to plug it in, would satisfy this equation. And finally, we can graph it. Nice visual diagram of the relation. Now, there's not one representation that's the better. They each have their own uses and purposes. In science, you might start off by gathering data and putting your information in a table. You might then graph it, and from the graph you see a shape, and from that shape you form an equation. Or maybe you're given the equation of the relationship. You want to graph it, so you make a table of points in order to graph it. So, there's different ways you can use the information. Now, the domain of a function or a relation is all of the inputs, and typically we call them the x's. The range is all of the outputs, and typically we use the y variable to use that. Now, let me go back to this page, and let me just look at the domain of this relation. It's the input. It's the x value right here, right here. The range, similarly, can be picked off easily in these different representations. You notice I skipped this one down here. Now, I think it's actually critical that we can identify the domain and range from a graph. That's a little harder. The idea here is that we're asking for every single point in the relation, we're saying, what is the x value? 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 When we answer that question, we have the domain. So here are the x values for all the points in this graph. And you notice that in some ways we're kind of casting a shadow of the graph upon the x-axis. And in an analogous way, we can cast a shadow of these points onto the y-axis. So this point, a shadow is on here. We have a point here and a point here. And so now these values in yellow match these values in yellow here. These values in green match these values in green. And if we had a more complicated graph, like, say, I don't know, like that, for example. In that case, again, we could kind of think about the shadow. We think, well, what is the x value here? What's the x value here? What's the x value here? What's the x value here? The shadow of the graph upon the x-axis will be all of this. The shadow of the graph upon the y-axis, if we had light shining in this direction, if we had light shining in this direction, it would cast a shadow something like this. So this would be the range, all numbers less than this amount. Okay, so that's domain, that's range. Now let's talk about a function. A function is a special type of relation. It's a relation where every element in the domain, every element in the input has exactly one element in the range, not more than one. So for every input there is only at most one output. So in this case over here, you see that we have input of 1, 2, 5, and 4. We don't have a repeated input value, so it's a function. But in this other case here, notice this. We have 3, and it's 3 is paired with 6, but 3 is also paired with 4. 3 maps to 6, 3 maps to 4. That's a relation. Here, if I have something in tabular form, I can notice, I just look at my inputs. That's really going to tell me everything. It's not repeated. There's no repeat inputs, so it's a function. In the case of a graph, in this particular case, you can see that this x value here has an output value up here as well as down here. One input has two outputs. That's a relation. So this would suggest a way of testing a graph. We have what's called a vertical line test, and if a vertical line test is swept across a graph, if during the sweep it intersects at more than one point, it's a relation. So in this case, as we sweep this vertical line across this graph, it only intersects at one point. So it's a function. In this next case here, it starts off with the vertical line starts off intersecting at only one place, but then as we continue our sweep, it intersects at 3 places. Oh, that must be a relation. The next one's a function. The next one's a relation. Okay, let's talk about function notation. We define a function with this kind of language. And in this case, it's not f times x, it's f of x, where f is a function name. So it's all about context. In this context, it's not multiplication. And so what this phrase is saying is that, or what this notation is saying is that we take our input, and in this case x is called the input, and we add 3 to the input. That's what the function does. So if f is the function name, and it can be any letter, it can be a, it can be t, it could even be a combination of letters. It could be a name like cost. So I have a cost function. Or maybe I have c sub 1. So maybe I have many c functions, and then I have c sub 1. X in this case is the designated variable that we're using for the input, but it doesn't have to be x, it can be any letter. It can be y, it can be h for hours, and the input actually can be a mess of an expression. Okay, so why don't you do these problems and I'll show you the answer in 3, 2, 1. Just a quick note. Do not cancel this. Cannot cancel here. No, that's wrong. Now, if we had c times 3 over c, okay, in that case, we can cancel these out, because the reason why we can do that is that it's equivalent to c over c times 3, which is equivalent to 1 times 3, which is equivalent to 3. So in that case, it's safe to quote-unquote cancel. But that's the only time. And this case is different because of the addition right there. Okay, some common functions to review. We have the constant function. The constant function graphically will just be something like this a horizontal line at a height of c. We have the identity function, which is just a line of a slope 1 through the origin. We have the absolute function, which looks like a V shape. We have what's called the greatest integer function, and I like to write it like this actually. There's different ways. I like it this way. And we also call it the floor function. And let me describe what it is. The floor of 5.16 is I go down to the nearest integer 5. Pi, I go down to the nearest integer 3. Negative 1.4, I go down to the nearest integer negative 2. Note, you just don't cover up the decimal here. It works for positive numbers, but for negative numbers it doesn't work. You actually have to go down to the next lowest integer. The graph of it would look something like this. All numbers between 0 and almost 1 will get floored down to 0, so hence this piece. Then all numbers between 1 and almost 2 will get floored down to the y value of 1. Now we start seeing a pattern, and we just replicate that pattern. Okay, last thing is for you to do. Just try to do these problems, and I'll show the answer in 3, 2, 1. Okay, little things to note. In this case here, make sure when you're writing it, you don't just square a piece of the input. We need to put parentheses around it. We square the entire input, because that's what the function definition is saying. Take your input and the entire input gets squared. Okay. All right, that's it. Have a good day, everybody.